Welcome everyone to ModX Virtual Exchanges. We have another ModX Network voice joining us today. I'm Ryan Smith with ModX in Washington State University, and I'm joined by Ivan Rupnik. Ivan, why don't you say hello?
Hi, Ryan. Hi, Helena.
Helena Lidelöw is joining us, and she is from Lindbäcks Bygg, which is a development construction company that has leveraged offsite construction in Sweden. And she is going to be speaking with us about a number of ideas surrounding offsite construction. So we will share a screen and we will go from there. Now, Helena has been a great partner over the years. Helena also has a background in academia, and I'll let her introduce herself shortly, but ModX has been fortunate in that she's come with us on a number of adventures to Japan, and she was with us in the Northeast, and we've known Helena for a number of years as a leader in the space. Helena, do you want to introduce yourself and a little bit about your history?
Yeah, thank you, Ryan. I'm happy to join you. And yes, I've been working in the modular space for over 20 years now, and as being part of the Swedish community for modular. We have a long history of doing prefab, so I'm really happy to be able to share some of the experience and maybe learn from others. I have a background in academia, so learning is very strong for me, and also very happy to join the ModX community and contribute to it, and hopefully we can do more in the future.
Well, thank you, Helena. We're going to go into our first slide here, and I'll frame this for Helena to talk about. If we look at business and industries, one can distinguish between two clear definitions of what might be considered a product industry and what might be considered a service industry. And service industries, historically, like say law or accounting or things that have a high touch service orientation, are really defined by the number of customer or client inputs, right? The amount of input that they give to the service provider. And that high touch client connection defines it as a service industry. Product industries, you might consider to be the other side of that, which is they want to limit the client interactions, and that increases productivity and really their revenue and their ability to run a business. And so it really becomes difficult to define these two ideas of service industries and product industries in the design and construction industry, because we're really kind of both, right? We do both. We meet clients' needs, but we also build a product. And so Helena is going to talk a little bit about a couple of charts here and this theory and how it plays out. And then we'll look at some case studies and examples of this throughout the world. Please go ahead, Helena.
Yeah, thank you. And the chart that you're looking at is supplier client side. So the line that is diagonal across here is really delimiting how much the supplier can do in advance, which is the black part of it, and then what the client will have as an impact space, which is the blue part of it. So take, for example, a very simple product that we buy every day, which would be a bottle of milk. It would be shipped to stock, which is the lowest tier in this diagram. And it means that everything is governed by the supplier. The production of the milk itself, the bottle, the container, the transportation of it, it's shipped to stock, to the store where you pick it up. And you as a customer, you have the only choices that are displayed on the shelf and nothing else. And you're pretty happy about that because you are happy to get a bottle of milk, and the variations will probably cover your needs. And if you need something else to happen, if you need milk, for example, that's not coming from animals, there has to be product development, and a new product will then eventually reach the shelf. Now, what the industry discovered is that you can actually transfer this idea also to production of cars. So in the beginning, when we made cars in the early 1900s, cars were made custom made, and they were one of a kind, all of them. So the idea of doing mass production didn't really catch on until later. And then after a few years, also the Japanese companies perfected this idea of the made to order, which is the third tier in the diagram here. So when you enter the website of, for example, Toyota or Audi or Chrysler or whatever, you can click and you can choose and you can have your own special car. And you feel very good about that. So you have many choices. The thing is that you don't really have that many choices. The manufacturer is just displaying the degree of freedom that you have. So you feel empowered as a client, but what you're actually doing is designing the order for the factory to produce your car. And when we enter the construction space, which is mostly the engineer to order and at times concept to order, the highest tiers, you see that the black part of the line here is very small. So we work under the engineer to order, which means that design is part of the production. So the client has a very strong impact on also the design part of the product itself, which means it's very difficult to create standardization and create repetitiveness, all of those that are needed to be successful in manufacturing. And what's interesting about the modular space is that the modular space kind of crosses over between the engineer to order and make to order space. And this is where manufacturing principles come in, which I feel is a very important contribution to the modular space to understand as a principle, because we are working with factories. Mm. So if we move forward to the next picture, I think that there are also variations within the construction space. So this is all engineered to order. And if we work in normal construction, what people mostly recognize as construction, we're working on the top tiers. So we just do standardized, customized design. And we go forward with the architect and the developer and the contractor and so forth, and almost nothing is standardized. You can get what you want, and that's the good thing about construction, is that you can get what you want. But the bad thing is that it tends to be a little bit expensive, and it tends to be a long time for delivery. So modular construction has really started to explore the lowermost tiers, where you have some kind of standardization and you expose your clients to selective variance. Thing that I observe when I work is that companies and other actors they're not used to that. So most of the clients that we have in construction, they're trained to do the top tier design and manufacturing space. So when they are exposed to modular alternatives, they are pretty much used to get exactly what they want. Mm-hmm. And getting what you want is also at a higher cost level, and it's a longer time frame. And it doesn't match really well with modular production and factory production, because what we mostly need is standardization, repetition, and being sure of what we're going to do next. So I think that this diagram is useful when you start working with the manufacturing principles. And it's also useful when you try to educate people about what is the difference then between the construction logic and the manufacturing logic. So
I can ask one thing, Helena, while we're on this slide too, is can you give some examples of open building systems in terms of prefabrication?
Yeah, definitely. When you work with open building systems, they are the ones that we're used to pick and choose more or less from shelves. Mm-hmm. So it could be precast concrete slabs. It could be columns in steel. steel beams and some connectors that are just hanging around. And we're so used to them being there as standardized components, so we don't really consider them being building systems. But when you start thinking about it, you can actually have a manufacturer of steel components give you a catalog, and it's for you to choose and combine from. When you move further down, I mean, you can have a closed building system, and then it's a bit more difficult. You're maybe not given a catalog. It's a proprietary thing.
And would you say most modular systems are closed building systems?
I would say so. They are closed building systems in the sense that it's more difficult for an external designer to affect the system. I would say that having that said, inside the box, most modular systems, at least the one who are with the timber frame, are very similar in construction. So I've traveled extensively and met a lot of manufacturers, and I can say for sure that there are no such thing as a patent or a unique solution or something that even resembles competitiveness in the kind of solutions that you choose. So for me, we're sharing the same basic technology.
Great. Great. So yeah, we wanted to, again, as for the ModX audience, we really find these two diagrams for Brian and myself, both in terms of terminology and as conceptual tools, we really are indebted to Helena and to others who have been developing these. These aren't, again, like the standards in construction and Helena just alluded to. These concepts are in the manufacturing space and to some degree in the construction space, but we really feel that, again, through this conversation, we can really start to standardize the use of these tools, not of these conceptual tools, not just the building components themselves. And it's really key that we start to develop a much clearer set of standard terminology. Otherwise, it's very hard to move forward. And so with that, I wanted to move to the next step of our conversation, which is really to walk through some systems and some context and ecologies that we've all, actually Helena and Ryan and I have had the chance of looking at together. Sweden, the US, Japan, and maybe back to the US again. So this is a photograph from a tour Ryan and I had in 2017 of Lindbäck's old plant, which was very sophisticated. I know it's even more sophisticated now. And one of the things that we're really impressed with in discussion of open, closed building systems, but also standardization, was the degree to which panelization preceded the volume, and the degree to which there was both a combination of a highly standardized system, and yet also a high degree of customization in the way that the panels were combined, and in the way that the volumes were even combined. And so we wanted to maybe, we'll walk through these in detail, but looking at the kind of basic process of Lindbäck's. Can you talk a little bit about how the diagram that we just looked at has helped you make decisions in the development of your product platform at Lindbäck's?
Yeah, we operate with a closed building system then, which is a modular construction system. And the thing that we do that I see differ from factories in the US is that our panels are closed. So it means we finish them up. So the wall panels are, before they enter the modular line here, we have closed them with the sheathing, but we also have the electrical wiring. And if it's an outer wall, we also finish on the outside. So we try to remove work from the assembly line. And that is because we know that if we have a lot of work on the assembly line, it will be slow. So for us, the takt time is really important. And the takt time is the time it takes from one module to move one step ahead on the assembly line. So what we have done is actually the same move that the manufacturing industry at large has done. And especially if you look at the assembly line of a car manufacturer, they constantly remove work from the assembly line and move it out into being modular components that just enter the line and just are simply assembled into something that is created as a component. And what you're looking at here is our building system. So what we have is not a platform frame. Our floor and the in ceiling is hanging on the wall. So this is a balloon frame.
Mm-hmm.
And for us, that has been successful because we're operating in the climate that really needs a lot of insulation. So for us to have that platform sticking out and creating a thermal bridge is not a good choice.
Mm-hmm. And can you talk a little bit about, so it's interesting, you sort of alluded to the way that tack times are, the way that you look at the manufacturing process and make decisions. And we also know, Lindbäcks, if correct me if I'm wrong, had been producing a panelized product for quite some time, since maybe the 1960s or 1970s, and moved to volumetric in the 1990s, let's say. And so was the process of some of these decisions about making closed panels and assembling them, was that a deductive process? Was it an empirical process? How did the feedback loop work in that development of?
Yeah, you're right. We started by doing closed panels, and that was not a very strategic decision at all. I think it was just the way of operating that we have in Sweden. So for us, the closed panels that are done in the factory and transported to site has been part of our history for very, very long. And I think it has to do with the climate again. You want something that's closed up and done, because it's so cold to be on the construction site. So you don't want to stand there and fiddle around with your electrical wiring and your ceilings and your gaskets and so forth. You just want it to be clear when you're on the site. So we did that for a number of years, and something like 35 years, and built fairly low-rise construction, 2 or maybe 3-story buildings. And in the early 90s, we had a huge crisis in Sweden. 1/3 of all the construction companies just went out of business. And for us, that was, of course, devastating, as it was for any other construction company. So we just needed to flip the cost structure of what we were producing. So instead of having carpenters on site assembling flat panels, we moved the work into the factory, and our factory is in a rural area, so the the salaries are lower, which means that you actually can benefit from moving work. So that's when it was just a chance that we took to start with modular construction. And that resulted in the factory that you're looking at now. So from 1994 to maybe 2009 something, we developed the building system continuously. And during that time, we learned, of course, that first making it manual, and then it's easy to produce something like 2 modules a day. You can do that just by moving stuff from outside under a roof and then organizing stuff. And then when you reach 4 modules a day, it starts to become a little bit, okay, now we need to think about logistics. We need to think about who is going to deliver materials in a sequence to the flow line. Otherwise, we will not be able to keep up the pace. And somewhere here along the line, for us it happened around 5 to 6 modules a day. We realized that it's not enough with people. We need to work with automation. So we have an automated wall line that has been part of our operations since 2009. And a wall line is nothing unusual in a Swedish manufacturing environment of housing components. That's something that every other factory of considerable size has. And we just have started to do that. And when we entered the new factory that was opened in 2018, we are then on our second cycle of a wall line. So now we have something that is even faster.
One more question related to this, which relates to the recent McKinsey report from 2019. So the McKinsey report of 2019 focused more on modular construction. In fact, they looked at closed panels as a form of modular construction and volumetric as a form of modular construction. And they in a very simple kind of broad view, they looked at panelized product as being slightly more open, shall we say, or customizable, and volumetric as slightly more closed. And then, but that with more cost benefits, is sort of what you've alluded to. Then they also suggested a third alternative, which had some benefits in terms of investment and in terms of economy, which was like what they call the hybrid 2D, 3D approach. And what we see here, though, is that in terms of your automation, in terms of your capacity, while you are primarily making 100% making volumetric product, you have the capacity and you even have some of the logics of a panelized system within that. So can you talk a little bit about the benefits of that approach, the benefits of what is inherently both a 2D panelized and a 3D volumetric approach in terms of the production logic, and what it allows you to do in terms of responding to clients?
Yeah, that's an interesting question, actually. Since we don't have any standardized houses, I mean, we don't operate with the catalog. It's very important for us to be able to meet the architect's needs. And that means that we have to be able to create spaces that are not necessarily done well in modular construction. So if you look at a floor plan of ours, it's not like mod, corridor, mod. That was what we made the first 2 to 3 years. And then we realized that this is not going to work for us. The market is not
too small.
Enough.
Yeah.
So it was too limited of a scope. And since we then had that history of being able to do plant panels, both floors and walls, it was possible for us to have that combination. So we still have a part of our flow line where you can make flat elements that complement the modules. So for example, the corridor is a fold out. So we have a little floor that hangs on the mod, and when it comes on site, we just flip down and it becomes a floor. And then if we need to do something that's more open space, we can produce that as a flat element and just send it with the trucks all the way to site. We've also started to combine a little bit with CLT, and much as you do in the US, we're also using concrete podiums, but we also combine with steel podiums at times. We need something that's a little bit more open space and doesn't really lend itself well to mods.
Yeah, I mean, it sounds like, again, what's really very interesting to hear that you even tried what in the US people see as the holy grail, which is quarter unit, and found that it was too limiting for the market and for the kind of investments that you were looking at. It sounds like also that standardization, we often tend to, in the US, talk about standardization as customization as two binary ideas as opposed to a kind of continuum. And what's really impressive, and again, it was really shocking and very positive experience for us when we first saw your system, was that it was very familiar and very innovative at the same time, because we could recognize the lightwood frame construction and all of the volumetric components, but the decisions of what to standardize and what to leave for the market or the client to customize is really different from what we've seen in the US. Although we in recent experiences, for example, in Seattle, when we did our tour that Ryan organized, we started seeing, just because of pragmatic issues, smaller mods because of urban sites. In your case, the smaller mods sound like both flexibility of floor plan, but it also it seems from the production logic, it also has something to do a little bit with the equipment that you use to panelize as well. Are those the two key factors that drive the module size for Lindbäcks?
Yeah, you're absolutely right. I mean, our mod size is smaller, so something like 4x8 or 4x9 meters would be normal for us.
Yeah. And so 14 by 30 feet, more or less, which is what we're seeing in urban areas, even in the US now.
Thank you. Yeah, so we don't have that restriction of having a large load that needs to be one load when it goes on the truck. For us, it's okay to load 2 of those mods onto one truck and go. And also when you say for the equipment in the factory, I mean, it's half the size, it means half the weight, it means half the material, it's half the stretch you need to travel when you walk across the mod in the factory. So everything is faster when you have a smaller mod. Having that said, I mean, a large size mod is probably also a good idea because you have a lot of square footage that goes out the factory door. So there is kind of a balance here that's interesting to feel out, which is probably different in different areas of the world, I'm reckoning. And I don't think there is no such thing as a right answer.
Right.
But there is probably optimizations to be done within the settings that we operate. And for us, this has been successful so far.
Yeah, and I think that's a key point too, is that for us to remember that standardization is more optimization than looking for an ideal. It's more about it's open-ended. It's not we are not going to arrive at the perfect mod size. In fact, that doesn't exist. But there is a.
No, I agree with you. It doesn't really exist, and I think maybe the thing is that you have to take into account so many factors. So you're absolutely correct when you say that it has to do with customization. And for us, the customization was key. I mean, we're only 10 million people in our country, and we only operate on Swedish ground. So the market size from the beginning is not that much. You need to organize an investment like this to be able to support quite a heavy portion of that segment. So we know that within the factory here, we can supply to somewhere around 85% of the multi-story building area. And I think that's enough. And we can say no to the 15% that doesn't really fit our building system.
Okay, well, I mean, we could spend. Lindbäcks is really a fascinating case study, and we love talking about Lindbäcks, and we will be hopefully coming back to Lindbäcks soon when the travel restrictions lift. And we're also planning on doing a preview of that tour relatively soon in the summer as a way to virtually prepare for our trip. But maybe shifting a little bit back. So we have Helena here. Helena's not only familiar with Sweden, but the world, and maybe shifting to Ryan as well, maybe talking a little bit about the US and how we can apply similar ideas.
Well, most of the listeners here and participants with ModX understand the difference, but for new audiences, there's HUD code, which is on the left, which is considered a manufactured house where the chassis is with the unit for its life. It's built to a different code than the one on the right, which is the IRC or the IBC code, standard code. The chassis does not stay with it, and those are built to the standard construction code and then assembled as boxes on the job site. And so, you know, Helena has consulted with a number of companies in the United States as well, and not to point out any specific company, Helena, but we thought maybe there were some lessons or some observations you've been able to make of the US market, and some things that you think are interesting or are done well, and also some things that maybe need to be learned, need to be understood better by the US industry from your observations, if there's any you could give, with respect to general comments, but also specifically about this notion of you know, standardization versus customization.
Yeah, I think it's really interesting to travel and learn what others are doing. And of course, you can never avoid to compare with where you come from. So I automatically do that. So one of the things I see when I enter the factory floor is, of course, the obvious things is the size of the mods, which is, they're huge in my eye. So the handling of them and the shipping of them, and I'm fascinated that you travel around with so heavy loads. And I also understand that it takes it's quite an effort to treat them well also on the factory floor. You need a large space on the assembly line, and you need to push them around with very heavy lifting, For me, that's a little bit cumbersome, so I like them to be smaller. And the second thing I recognize when I look at it is that I come from an upbringing where logistics is very important. So for me, it's super important to have pre-cut materials. I like to have the studs done already before they enter the assembly flow. I want to have kitting of the parts that go into here. I like to have an orderly sequence of when things are done and at what station they are done. And when I enter some of the factory floors in the US, it's crammed, it's a little bit dark, it's difficult for people to move around. The workers have to go fetch their materials themselves. At times they bring their own tools in, and for me, it's difficult to understand how do you keep up the quality at such a level that it will be consistent across the production line. But I also see that in terms of technical solutions, I mean, the structure itself, it doesn't really differ that much. It's a timber stud frame. That's it.
Yeah.
So there is no magic with that one. You usually do platform framing, which is totally understandable since the mods are so large. So you want to have that strong base on the floor so you can handle it. It makes perfect sense. But when you start building on height, platform framing eventually becomes a hindrance for you.
Yeah.
So you have all this lumber that you're compressing across grain, and it becomes a lot of settlement in the structure. So that hasn't been really successful for us to think about platform framing. That's another reason for us to go with the balloon frame.
I mean, and that's why we also like using this image is in a way, while the modular manufacturers work within a much more stringent code, whether it's the IRC or the IBC, we tend to find that there's still a lot of residue from an earlier product logic, which was the manufactured home. So even more recently, the shift to multifamily is still relatively new in the volumetric modular space in the US. And so a lot of vestigial organs seem to have remained from when either we were making trailer homes or single family homes. And again, now to the degree to which people feel comfortable shifting over is something that, again, people have a lot of anxiety. There's been the boom and bust cycle has created a lot of anxiety among construction industry, and modular industry is no different, which maybe explains a little bit why some of the characteristics of the U.S. industry. You guys came from a panelized industry and moved into volumetric. In most cases, whether the manufacturer was making trailer homes or not, and again, modular is different. Modular is higher quality, but those protocols we tend to find are persistent and maybe need to be re-explored. One thing I wanted to just make sure that all the audience knows: how high are you able to go with your balloon frame volumetric modular buildings?
Yeah, we're constructing between 4 and 8 stories.
Right.
So for us, the 8-story limit is actually governed right now by the fire restrictions. I could go a little bit higher if I needed if I look at the structural material, but the fire restrictions are a little bit harsh, and it would introduce a little bit too much cost, I think, into the building system to cope with that.
But it's important, again, for our audience, especially those in the modular industry, we are not able to build, we do not have systems that are able to go up to 8 stories in wood right now. It's not just a regulatory issue, it's also the building system itself. And I think some of the mod sizes, it seems, and obviously the choice of balloon frame versus platform frame have certain benefits, which goes back to your point earlier about the investment in automation, the investment in plants, and making sure you have a large enough market that can serve that investment. And so it's interesting to think about can a module, which also can make a 4-story building, make an 8-story building, means you're looking at a much larger potential market. And that's something, again, that's why we always like to use this. And it's become, from having a dialogue with you and with Sweden and with other places, that vestigial organ seems to be much clearer now. But also the fact that from a customer side, the trailer home had a significant advantage because it was almost like your milk example, it was a product. There was a dealer. There was a whole structure that still exists, which is quite efficient. You can choose some finishes, but basically it's truly a highly standardized product. The modular space in the US is still not clear about how much to standardize, how much to customize, and not to mention how those two are actually parts of the same whole.
No, it's very interesting with the history and the development of the manufactured homes. We don't have anything similar in Sweden because our code is not divided into two tiers. Mm-hmm. So we have to meet the normal code. Yeah, the same code with regardless if it's a modular.
Whether it's single family,
yeah. So that's the thing. But I have to say that I admire the manufactured homes from a perspective of being able to supply a very large market with good enough homes for many people. They have done that on their own merit. Yeah. It hasn't been much support for the industry. No. So that's applause. I mean, that's a building system that has been around for decades.
Yeah, since the 70s. And in the 90s at its peak, it's kind of declined. 1 in 3 single family homes in the US was a trailer home, which is pretty impressive. And so, and maybe following up on that, one of the things we've noticed, again, this is looking at Lindbäcks on the slide here and some more typical US systems. Again, to try and do some comparisons, to the degree to which your process of high quality standardization, even the land management of your forestry results in mods that, while they might be smaller, have very high tolerances and have there's a high degree of structural stability, which results in things like being able to finish to a degree that is in the US more comparable to a steel system. In our case, the mods themselves, again, but not only the size, but the joints themselves are still based on kind of a single family logic. So you might have 2 or 4 mods. You're not looking at these. And so the kinds of decisions about, from a supply chain perspective, from a standardization perspective, from an automation perspective, are actually hindering the degree to which we're able to start to grow into the multifamily sector, right? The market wants it, that we've made these promises, and yet there's a lot of I would say a lot of the supply chain, a lot of the production side is keeping modular from being able to effectively address a serious need, which is multifamily, as opposed to, again, the decisions up front, the decisions that even beyond Lindbäcks, even beyond the modular industry, about the quality of lumber and the panelization. So what would you say if you had to rank the factors? What factors most directly contribute to the high tolerance of mods and the degree of finishes in the Lindbäcks system?
The quality of lumber is important. So we do have we're spoiled with high quality lumber here, especially in the northern part of Sweden. It grows slowly. We have a finished tree is somewhere around 80 years old, and it's very dense with the annual rings. So the dimensional stability is good. We're also spoiled with Sweden being one of the largest exporters of lumber in the world. So we're sending actually some of our lumber all the way to Japan. And the Japanese people are picky about quality, so you should take note that this is it's a high standard. But it gives us the possibility to produce panels that are very close to the nominal dimension that you need. And it also opens up the door for automation. So machines are very, very peculiar about dimensional stability. If you're a half a mil off, the machine will not execute. So that's something you need to take care of. And I think that's why automation and steel is such a good mix too. So on the picture you had earlier here, you regularly place your mods something like 2 inches apart, and you see the difference in height between them here. And I would reckon that you will also see something else when you make the building even higher, and that is that your modules will probably either spread apart or they will close together. So you will have not only the dimensions in 2 dimensions, but also in the third dimension. And to be able to control that, you need to have something that's closer to what you see here. And we regularly have our mods spaced a little bit less than an inch apart. And as this detail that you're looking at here is the close-up of the floor. So what we will have is a mirror solution. So we put 2 mods beside each other, and then we close that gap with just a sheet. And it regularly doesn't differ more than maybe 2 millimeters between the two beater. So that's, I think that there is a lot to gain when you would start working with tolerances. And again, it comes from the manufacturing principles. I mean, once you start to pre-cut your lumber and make sure that it's cut to the same dimension every time, and you order lumber that is with a high degree of stability and dimensional stability, these things start to happen. And it opens up possibilities.
Yeah, and it's frustrating often to hear in the industry that people discuss automation, quality lumber as if they were luxuries, as if, and it tends to, for us, it tends to reflect the fact that the industry in the U.S. still often lacks a manufacturing lens, and a manufacturing lens doesn't necessarily mean automation. It means knowing how much things actually cost, knowing real costs, and being able to assess those costs.
That's true. And one of the things that I often meet too when I speak, and especially to US companies, is that they say, we don't have enough capacity. And I go to their factories and I see there are tons of space. And half of the factory is full of materials. So there is capacity. It's just the matter of recognizing that if I could move the mods half the time, of what I do today, because I have seen modules in the US sit on the floor for days and for weeks, And I mean, if one module passes through the factory door after 4 hours, and if you just could imagine what you need to do to have one every 2 hours, that's capacity. So there's a lot of investment that you can do with what you have, if you just recognize that you need to make a little bit more expensive decisions when it comes to materials and equipment, but you gain a lot in the end.
Well, you gain 4 stories. You gain 4 stories of capacity. If you go from 4 to 8, that's a lot of money. 4 stories is a lot of money. So it's taken us, I think it's taken us a while to also even pinpoint where the resistance is coming from. And again, it goes back a little bit to tradition. It goes back to, not that anything wrong with tradition, but the perception that we are actually manufacturing when in fact we're not. And our understanding of manufacturing is not only not in line with what you're describing in Sweden, it's not what manufacturing is understood by American companies like Boeing or Apple, or you pick, even service industry that shifts on automation. Ryan. Okay, so I think one of the pleasures of working with Helena is not only on getting to know Sweden better and understanding the US, but we've also had the luxury of looking at other contexts, and one of them is Japan. So we all took a trip last May and hoping to do it soon again. Again, we've seen Sekisui Heim, probably the largest and one of the more established volumetric companies. They've had their light gauge steel system around since the late 60s. And again, it's an interesting combination of both a highly standardized volume made of actually a kind of panelized logic and a kit of parts logic, and a high degree of customization in terms of plan. Some of the things at the single family scale, some of the things you've described about being able to both standardize and customize, something we saw in Japan. Again, surprising when we saw that there are 90 kinds of volume variations, which seemed like a lot. And then we understand that standardization actually happens at a different scale. So they, in some ways, similar to what you were describing in Sweden, the understanding of where to standardize and what to standardize is obviously key, and having that experience both from the factory side, but also from the customer input side. And we saw that in wood as well, both an approach to panelization before volumetricization, as well as the same logic of standardizing panels, standardizing assemblies, and making sure that there's a lot of customer input. And we also saw, again, a kind of two sides of a similar coin. In Sweden, you're blessed to have a great natural resource. In Japan, they either import high-grade lumber from you, or they import medium-grade lumber from Canada and re-engineer it for the same dimensional tolerances. So so what's interesting again is the importance of nominal consistency, whether you're looking at it through the supply chain and land management, or whether you're doing it at a factory and really engineering your own products. Whichever approach you choose, it seems like in the wood space particularly, that investment is not a luxury, it's a necessity. So anyway, this is just, and then just sort of looking at it again, the idea of being able to build a standardization system to support customization, in a sense that the two are linked. That we can see here, this is their flow from planning to delivery, and it's for a single family product as opposed to a multifamily product. But again, the idea that that a highly standardized system actually supports customization. So anyway, we'd love to hear again your thoughts. We shared this trip on what do you see? What are the lessons, key lessons from Japan? How are they comparable to what we've seen in Sweden? What can we learn from them in the US?
Yeah, I think the Japanese trip altogether was fantastic. I mean, being able to see a building system that operates so well was very interesting to me. I think one of the things I learned is that, first of all, their size of modules is very small as compared to ours too.
Mm-hmm.
So there's something around 2 by 5 meters. So it's 1/3 or maybe half maybe of ours. But it turned out that they had another limit of transportation, of course. So they couldn't really, it's a country where it's a tight space. So they needed that for their customization. And then also their very orderly customization, which meant that they have a range of modules, but they are organized in such a way that you can combine them into very many different buildings. The entire customer experience that was built up around that. So for me, it was also interesting to learn that modular buildings were considered higher quality, and you could charge higher prices for them because you had a factory process in the background that warranted a very high quality end product. So, and it wasn't something that was questioned. This was the natural mode of operation. So that was very interesting for me that their entire marketing was built on quality, customization, and trust. So it was frequently displayed that research was behind the results that we saw in the factories. So I think that was a lot of lessons to learn there. And again, it's coupled to the culture. It's no surprise that this is very similar to, for example, the description of Toyota manufacturing, which has the same basic principles, just applied to buildings. And then
is there anything specific we might see in Lindbäcks from Japan anytime soon?
Oh yeah, I would love to have. I would love to start working or experimenting with the customization of their modules by maybe developing a building system that's with standardized modules, highly standardized modules, because I can see how they push the price point at the same time as they rise the quality. So I think that would be interesting to experiment with.
Yeah, and we can see that almost from the panels that you have, the closed panels, almost some of the mods becoming as standardized as some of those panels in a certain market share. Great. And so just in wrapping up, one of the things that I just wanted to point to, and this is another part of our network, Connect Homes, which is a single family manufacturer and actually for vertically integrated design, manufacturing, assembly out of Los Angeles. Some colleagues of ours, interesting hybrid system with a highly standardized chassis that's steel, structural steel. It's actually it's the 2.4 meter width, very small, very tight, and long like an American model. Panels short like a Japanese one. Interesting combination. And again, high grade for U.S. standard, but high grade, fairly flexible light frame infill. highly standardized mod. But again, last visit, we're also hoping to visit their factory soon. We saw the company's been around for about 10 years, but very recently has acquired a new manufacturing space. The head engineer of the production line is a British gentleman who has had experience in Japan and Sweden. So again, we starting to see this is what ModX is kind of all about, and we're happy to see that in this sort of world. We're really starting to see that these best practices are starting to emerge, but we're also gaining something that we think is important, and I know you share that as well, is that while we're looking for best practices that are general, we're also trying to understand what makes these markets and these ecologies specific. And I think so again, this weird, long, skinny module might be what the US has been, might be an answer. And even though this is single family, it might be also a way to think about a multifamily. But again, the idea that manufacturing doesn't necessarily, their plant, for example, does not have a lot of automation, but it has the kind of organizational logic that we see with your plant. We've seen with places like Bensonwood. We've seen with places again like Katera, who yes, maybe are also investing in automation, but that kind of company culture, that kind of planning is really what seems to be what's shared. And again, the kind of interface that they've developed, like Japan, in a way that says, here you want to feel what you were describing, almost more like the car industry. You want to feel an investment in the product, but you also want to control the cost, and you want to emphasize quality. So it's not just cheap and fast; it's dependable and high quality for a comparable price. So I think I just wanted to share that because I thought it was interesting to see. This was from a visit last May, that these things are starting to converge. And so maybe just in closing, based on our conversation, Helena, do you have any other big concepts you want to share with us? How do we start to apply this chart in our daily lives?
Yeah, I think it links a little bit to what you were just discussing here. In the modular community, when you do this cross-fertilization with manufacturing, which is starting to happen on a broader scale now, you're bringing in people who have that manufacturing experience. That's when it starts to happen. And that's when you start to build something that is more like a modular community of skills. And I think that skills are really important when it starts to apply to this diagram. So you need a whole new set of people. So for us, for example, when we started a new factory, it was not that important that you had people as carpenters. So we weren't actively looking for that. We were looking for people who can keep up a good pace, who understands flow, who are orderly and understands quality. So more or less people that came from production kitchens. We have policemen who are very, to the point. We have also on the design side, it opens up for new people because when you have high automation, you have machines. And when you have machines, the machines need to have instructions. And the instructions that they get is not oral. This is computer files. So you need guys and girls who are very good with keeping up with the computer development that's around. So we have gamers, and we have people who have been, working with CAD and automation for the last 30 years are in our community. And we see those as generics. We're seeing that as generic skills for the modular industry, really. So that's why I feel right at home when I go to the US and enter a factory there, because I understand the basic things they're doing. As the gentleman we saw just on the earlier picture, he's S and Q and so forth. That was part of his earlier experience, and it's just so familiar to him. So I'm very happy to be part of this development and also to build the skill sets that's needed to make this diagram true, also in other countries than ours.
And I think that's the whole purpose of ModX, and what we're trying to accomplish, Helena, is trying to be that connector and create a network for knowledge sharing, knowledge management in this space. We really appreciate your insights about you know, service industry, product industries, and how that plays out in Sweden at Lindbäcks and also in Japan. So thanks, Ivan. Thanks, Helena, for joining us on Modex Voices, and we will see you next time.
Great. Thank you, Helena. Thanks, Ryan.